Hi, this is Abhinav. Welcome to EdUTech Learning. Today I will discuss the remaining chapters of polynomials. In the last lectures, I have discussed about what is polynomials, according to the degree, how much types of polynomials, value of the polynomials, and zero of the polynomials. Today I will discuss the relationship between coefficient and zeros of the quadratic and cubic polynomials, and then some numericals also. If you have not watched my previous lectures, then please click on my I buttons on the top side and click and watch the first that videos and come to these lectures. My fourth topic is relationship between zeros and coefficient of the quadratic polynomials. Relationship between coefficient and zeros of the quadratic polynomial. Let x and beta be the zero of the quadratic polynomial ax square plus bx plus c. Then x minus alpha and x minus beta be the factor of the quadratic polynomials where the coefficient of x square not equal to 0. Here let x equal to alpha comma beta be the zero of the quadratic polynomial fx equal to ax square plus bx plus c where a not equal to 0. Then x minus alpha and x minus beta be the factor of the polynomials. Here what is meaning? What is the concept is actually telling about this? I will discuss in deeply. Here fx equal to ax square plus bx plus c and coefficient and zero of the quadratic polynomials, and it can be written as that x will be the some value where the value of the polynomials will be 0. Then x minus alpha and x minus beta will be the factor of this polynomial. It can be written as that ax square plus bx plus c equal to 0. It means that fx equal to 0 and fx equal to x minus alpha and x minus minus beta be the factors where k will be some constant. Why k will be some constant? Maybe it may be the coefficient of x square a 2, 3, 4, anything. As per the coefficient of x square, the value of k will depend on it. So I will take k is a constant. It is writing on board where k is constant. Then ax square fx equal to ax square plus bx plus c. It can be written as ax square plus bx plus c equal to k times x minus alpha x minus beta equal to 0. All equation will be equal because alpha and beta be the zeros of the polynomials, and it will be the factors so that it can also be written in these terms. And if we expand this, then what will be the results that I will get? I am expanding these factors k x square minus x beta minus x alpha plus alpha dot beta, and now equal to 0. K times x square k times alpha plus beta x plus alpha dot beta. Now comparing the coefficient of x square x with the coefficient of this main equation, then we will get some value of alpha and beta, that will be the sum of zeros and product of zeros, because alpha is the zero of the polynomial and beta is the zero of the polynomial. If we add it, then it will called as a new name, that is sum of zeros of the polynomial. Now I will compare it with the coefficient of ax square plus bx plus c. Here the coefficient of x square k will be equal to a. It can be written as on comparing the coefficient of same power of x, then we get k equal to a minus k alpha plus beta equal to b, and alpha dot beta equal to c. Here k equal to 1. I have already told that the value of k, constant k, will depend on the coefficient of x square, and I have to find about what will be the sum of zero of the polynomial. Here alpha plus beta can be written as alpha plus beta equal to minus b upon k. It means that minus b upon k. What will be the value of k? Here the value of k will be a. It is can also be written as minus of b. B is the coefficient of x. Coefficient of x upon a. Where is a coefficient of x square? And product of the zero. What will be the product of this zero? Alpha dot beta equal to, here alpha, here I have missed it. If we multiply k, it will multiply in every coefficient. So this k will be here also, na? And this k will be here also, and it can be written as alpha dot beta equal to c upon k. C upon k. What is c upon k? C is the coefficient of polynomial, constant of polynomial. Here c is a constant of the polynomial and k is the constant of the factors of the polynomial. Here k can be represented as a. It will be c upon a. It can also be written as constant term of polynomial upon a coefficient of x square. Now I will do some numerical, from which I will go into the deep that how to utilize these formulas to solve the numericals, from which I will get some idea. Now I am deleting this whole concept, and I will do again numerical. For the sake of the simplicity, I am writing the conclusion of this relationship between coefficient and zeros of the quadratic polynomial, and then I will do numerical. Here I am writing conclusion. First, if alpha and beta be the if alpha and beta be the zeros of the polynomial, then sum of the zeros of the polynomial alpha plus beta can be written as sum of the zero of the polynomial, sum of the zeros of the polynomial equal to alpha plus beta equal to minus b upon a, and product of the zeros of the polynomial equal to alpha dot beta equal to c upon a. Second conclusion, if alpha and beta be the zero of the polynomials, then the expression of the quadratic polynomial can be expressed in the different way. As it can be said that the expression of the polynomial can be represented also in the terms of factors, and here it will consider as sum of the zeros and product of the zeros. Then the expression of if alpha and beta be the zeros of the polynomial, then ax square plus bx plus c can also be represented as in the terms of sum of 0 and product of the 0. Here x square minus alpha plus beta x plus alpha dot beta, both equations are same. Here I have compared the sum of 0 with the coefficient of x b, coefficient of x is b and product of 0 is c. So both equation can be same, and as per the numericals I have to take the equations and solve the numerical. Here I will do some questions, and in from which I will go into the deep. There is one questions I am taking. The questions is find the zeros of the I am removing this concept. No. Firstly, I am writing the questions and solve it. If the boards will fill, then I will remove it. First question is find the sum of zeros and products of the zeros of of polynomial fx equal to x square minus 2x minus 3, and verify the relationship between its zero and coefficient, its zeros and coefficient. solution. Here polynomial fx equal to x square minus 2x minus 3. Here it is given that x is the zeros of the polynomial, so that fx equal to 0, fx equal to 0, and we expand it into the factor, then we will get some result. X square minus 2x minus 3 equal to 0. X square 3 can be written as plus 3x minus 3x plus x minus 3. There will be no change in the factors, and now I am expanding it. X will be the common, x minus 3 plus 1 x minus 3 equal to 0. Now compare with the 0, because it is a zeros of the polynomial. It means that x plus 1 equal to 0 and x minus 3 equal to 0. Then x equal to minus 1 and x equal to 3. Then sum of the zeros. Here x equal to minus 1 comma 3 can also be said at x equal to alpha comma x equal to beta. Then the value of alpha is minus 1 and the value of beta is minus 3. So sum of the zeros, sum of the zeros equal to alpha plus beta equal to minus b upon a, that I have already proved it. Minus b upon a, minus b upon a. So sum of 0 alpha plus beta 3 minus 1 plus 3 equal to minus b minus of 2 upon a 1. It can also be written as 2. So from the both equations, sum of alpha plus beta equal to 3 minus 1 2 and minus b upon a minus of 2 upon 1, both LHS equal to RHS. It means that both the equation are same, that I have discussed in conclusion number 2. And product of the zeros, product of the zeros equal to alpha dot beta equal to c upon a equal to alpha dot beta means minus 1 dot 3 equal to c is called minus 3 on 1. Both answer LHS and RHS will give the same result. The result is 3. In this way, I can solve all the questions related to coefficient and zeros of the quadratic polynomial. Similarly, in the case of cubic polynomial, relationship will be find out of product of sum of zeros and product of the zeros of the polynomials will be same way. In the case of cubic polynomials, I will do expression from which I can understand the concept in cubic polynomials also. It is my fifth topic, that what is the relationship between coefficient of and zeros of the cubic polynomial. Here fifth topic is relationship between zeros and coefficients of the cubic polynomial. Here the degree of x will be 3, so that the value of zeros, it means that the value of x will be 3 results, that x equal to alpha comma beta and gamma, and we will get some result. That what is result? Let alpha comma beta and gamma be the zeros of the cubic polynomial fx equal to ax cube plus bx square plus cx plus d. Then x minus alpha comma x minus beta and x minus gamma be the factors of the cubic polynomial. Here I will do the same actions that I have done in the earlier concept of quadratic polynomial. Fx equal to ax cube plus bx square plus cx plus d can also be written as k times x minus alpha, x minus beta, x minus gamma, where k is a constant. It will depends on the coefficient of x cube. Now I am expanding this and finding the sum of zeros of the and product of the zeros of the cubic polynomials. Here there will be three results: sum of zeros of the cubic polynomials, sum of product of the zeros of the cubic polynomials, and product of the zeros of the polynomial. I am expanding it, then it will reach it in the more way. K times x is k times x square minus x beta minus x alpha minus plus alpha dot beta x minus gamma, k times x cube minus x square gamma minus x square beta minus plus x times beta dot gamma minus x square alpha minus plus x alpha dot gamma plus x times alpha dot beta minus alpha beta gamma. Now I will arrange it. X cube, here only one x cube term, it can be written kx cube, x square x square x square, then it can be written as kx cube k times alpha plus beta plus gamma x square plus k times x alpha dot beta dot gamma dot alpha into x minus k times alpha dot beta dot gamma. Now I will compare the coefficient of x with this equation because both the equations are same. Now I am comparing it. On comparing the coefficient of same power of x, then we get k equal to a. I have already mentioned that the value of k will depend on coefficient of x cube a minus k times alpha plus beta plus gamma equal to b, k times alpha dot beta plus beta dot gamma plus gamma dot alpha equal to c, and k times alpha, beta, gamma equal to d. Here k equal to 1, a, then sum of the zeros, sum of the zeros, alpha plus beta plus gamma equal to minus b upon k equal to minus b upon a. It can be also written as minus of coefficient of x square. B is coefficient of x square. By coefficient of x cube. Sum of product of the zeros. Sum of the product of the zeros equal to c upon k. It means c upon a equal to c. What is c? Coefficient of x. Coefficient of x upon a. Coefficient of x cube. And the last is product of the zero. Product of the zero equal to d upon k. D upon k. It can also be written as d upon a. It means that d is constant term of the cubic polynomial. Constant terms, constant terms upon coefficient of x square. Coefficient of a x cube. Coefficient of x cube. Here I will get 3 results, and now I will do some numericals from which I will grab the idea how to solve this type of questions. Now I am removing this lecture. I am removing board, lectures board. Here I am also writing the conclusion. What I conclusion get from this expression of the cubic polynomials. Here conclusion. Conclusion. If alpha, comma, beta, comma, gamma be the zeros of the cubic polynomial. Cubic polynomial. Then first sum of zeros of cubic polynomial equal to alpha plus beta plus gamma equal to minus b upon a. Second is sum of the product of the zeros. Sum of the product of the zero equal to alpha dot beta plus beta dot gamma plus gamma dot alpha equal to c upon a. Remove it, minus d upon a. Here alpha dot beta equal to minus alpha dot beta dot gamma equal to minus d upon a. It was written as, it can be written as minus d upon a. I have removed this, and by mistake I have written. And third one is product of the zeros, alpha dot beta dot gamma equal to minus d upon a. And second, if alpha beta comma gamma be the zeros of the cubic polynomial, then it can also be written as ax cube plus bx square plus cx plus d equal to x square minus alpha plus beta plus gamma x square x cube, here x cube, here x square plus alpha dot beta plus beta dot gamma plus gamma dot alpha x minus alpha dot beta dot gamma. It can also be written as, both equations are same, it is in the terms of zeros. It is the general expression, standard expression. Now I will do numerical related to this topic. Numerical is find the sum of the zeros. Find the sum of the zeros, sum of product of the zeros and product of the zeros of cubic polynomial fx equal to, question is x cube minus 2x square, x cube minus 2x square minus 5x plus 6 minus 5x plus 6 and verify the relationship between zeros and coefficient of the cubic polynomial. Solution. Here fx equal to x cube minus 2x square minus 5x plus 6. I have to know the factors of this cubic polynomial that I have already studied in class 9th. Now I will put some value of x and try to get it 0 because fx will be 0 because it is 0 of the polynomial. Now x cube minus of 2x square minus of 5x plus 6. If we apply the value of x, the value of if we apply the value of x, now the value of x, if we apply x equal to minus 1, then it will be 0. No, it is x equal to 1. If we apply x equal to 1, then f equal to 1 equal to 1 minus 2 minus 5 plus 6. 6 plus 1, 7, 7 minus 7 equal to 0. Then x equal to 1, the value will be zeros. There is one values I have to find by your own sense, then the two results will come out by applying this x equal to 1. Because it is cubic polynomial, then it can be written as x minus 1 because x equal to alpha, x minus alpha, and x minus alpha. And now I have to arrange this expression. Here x, then I will multiply x square into x cube minus of x square minus of x x. So minus of x square minus 2x square minus plus of x, then I have to do minus of 5x. So plus of x, so minus of 6x, minus 6 plus 6 equal to 0. Expression, there will be no effect in the expression. It can also be written as x square minus of x minus of 6 equal to 0. Now I will expand this quadratic expression also. It can be expressed as 3 into 2 x square minus 3x plus 2x minus 6 equal to 0. X minus 1, x square, I am taking common, x minus 3 plus 2, x minus 3 equal to 0. The value of x equal to 1, x minus 1, x minus x plus 2 and x minus 3. It can also be written as it can equal to 0. It can also be written as x equal to 1 comma minus 2 comma 3. Now x equal to alpha comma beta comma gamma, sum of the zeros equal to alpha plus beta plus gamma equal to minus b upon a equal to 1 comma 1 minus 2 plus 3 equal to minus b upon a minus minus of minus 2 upon a 1 equal to 2 2 3 both are the same answer. LHS equal to RHS. Sum of product of the zero. Sum of the product of zeros equal to alpha dot beta plus beta dot gamma plus gamma dot alpha equal to alpha dot beta minus 2 plus minus of 6 3 into 2 gamma dot alpha plus 3 equal to c upon a c upon a c. What will be the value of c? Minus of 5 upon a. Now I will do minus of 8 plus 3 equal to minus 5 upon minus 5. LHS equal to RHS. And product of the zeros. Product of the zeros equal to alpha dot beta dot gamma. It means that minus d upon a equal to alpha dot beta dot gamma 1 comma minus 2 comma 3 equal to minus of d upon a 1 equal to 3 into 6 minus 6. So all answer are same. So I from this I know that the expression of ax is ax cube plus bx square plus cx plus d can also be represented in the factors of cubic polynomials. It will give as a sum of zeros, product of zeros, and sum of products of the zeros. Thank you, and I expect that you will understand all the concept of polynomials, and the next lectures I will do some numerical from which I will try to get more deep concept how to use how to use this formula in different numerical. Thank you.